Like what are the other things we need to explain? So now we know a lot many things about 8085. By now we know that what is a control bus, what is data bus, and what is an address bus. We know these things. Other than that, we also know different registers of your 8085. The registers are A, B, C, D, E, H, L. Other than that, there is one more register that we know, that is a program counter PC. Okay. Now, remember this registers are an 8-bit registers, and you can use them as a register pair of 16-bit. Okay, but only three options are there. Either you can use BC as a pair, D as a pair, and HL as a pair. And whenever you are using that as a register pair, at that time you have special instruction set. Okay, which are the special instruction? We have learned one of the special instruction, and that was LXI. The other one was INX. The other one was DCX. Okay? So whenever a 16-bit operation is there at that time, most of the time the instruction set, okay, the mnemonics of the instruction will contain X in between somewhere. But it's not all the time true. Okay? But most of the time X will be there. So for these three, you can see the X in between. Okay? So this we know. Other than that, we also know there are some control signals which we know. Let us describe which signals we know. The first signal we know is a read signal, the other one is a write signal. We also know what is ALE, ALE. What is ALE? ALE is the address latch enable signal. When we have learned that address latch enable, we have learned this signal during the timing diagram. Okay, in timing diagram we have seen this, that ALE goes high for half cycle. Every time you have 8-bit address on lower order address bus. We know this. What is the lower address order bus? It is your pin AD7, or let us say AD0 to AD7. So we know a lot many things. We know how to program 8085. But now let us understand that what are the other parts of 8085. Okay, there are some other registers present over there. For example, there is one more register known as a stack pointer. Other than this, one more register we know, and that is very important, is a flag register. A flag register has a various bit which will be modified whenever you are operating on some specific instructions, like you perform arithmetic operation, for example add, or you perform a logical operation like end. Okay, we haven't seen any logical expression yet. I will see it shortly. But before that, let us understand a generalized 8085 and what are the various pins on 8085. So now we are going to first learn the very basic 8085. I don't need this to do. I shared a book. Yeah, I shared. See, I have shared this book with you. This book is for 8085 only, and probably first 4 chapters are only for only useful for us. So what we are going to do, we are going to see part of this book right now, and we will be learning a pin diagram of 8085 and the architecture of 8085. That two topics that we will cover today. Is taking this first. See, whenever you've been asked in the examination, like draw the pin diagram and explain some symbols, at that time you have to draw this diagram, not this one. Yeah, this is the correct diagram. Okay? So, show it as a pins, like these are the pins. Okay, and name that pin, like what is the name of the pin. Okay, there are 40 pins, and this diagram, this one. This will be helpful to you when you remember like what are the various pins and what are the functions of the various pins, which are the input pins and which are the output pins. This diagram will help in that. Okay. So, but you have to draw this one in the examination. Whenever a pin diagram is asked, this is the actual pin diagram. Okay. This is kind of pin diagram, but it shows like which are the input pins, which are the output pins, and the numbers and bit altered. You can see there is one, then two, then direct 40. But actually, whenever you see the IC, in that IC, let us see the IC of 8085 first. We have already seen that during practical. Let's see one more time. See, this is how 8085 will look like. Okay, this one or this one or this one. Okay, let us say this is the 8085. So in this 8085, you see 40 pins, totaling 40 pins will be there. Okay, so this is pin number one. How to identify whether it's pin number one? Whenever you see any IC, there would be this kind of mark is created. Wherever this mark is there, besides that, on left hand side there will be a first one. Okay, so this is my mark. So respect to this mark, keep this mark in top, and whatever you see in the left side would be the first pin. Okay, so this is my first one. Generally, there will be one more signal over here. Little damp has been created over here in some IC, but as of now, let us say this is my IC. What is unmuted and so this is my IC, and there are totally 40 pins on your 8085. Like how that 40 pins will be there? 20 on each side of the IC. So 20 on this side and 20 on that side. How the number is written? This would be my first, as we know. So like afterwards, like this is second, third, fourth, fifth, up to 20th would be there. 20th pin is this one, then 21st is the bottom. Okay, on the opposite side, bottom is 21, and the top one is 40. Okay, so it's like this 1 to 20 on this side and 20 to 40 on this side. Okay, so that's how a pin diagram. So that's why we draw this diagram when we ask about pin diagram. So you can see here it's a 1 to 20 on this side and 21 to 40 this side. So actually, this is a pin diagram, and this is the diagram that will help you which are the input channel and which are the output channels. Okay, so now let us understand various pin of your 8085. Let me open clear picture. High resolution image here. I hope it is visible to everyone. Okay. So first of all, we'll be starting with these two pins, X1 and X2. Let me snip it out and take it in the pictures itself. Okay. So I hope this will be visible now. Now, now the first two pins, very basic spins are this one. I'm going to mark the one which we covered. So very first basic pin is this one, and also very important. There is a new issue with this pin. There would be low resolution. One node is not working fine. It will work. Okay. Okay. Now here the very basic pins are just two. First one is this pin, ground, and the other one is this VCC. Okay. These two are very basic pins. What we are going to do with VCC and ground? So we know that any IC that you use mostly require a power to operate. So that power would be given using the VCC and ground. Okay. VCC pin would be connected with a 5 volt or a 3.5 volt depending on the variant which you have. So there are a lot of variants of LED. You will see different numbers I see. So you have to refer the data sheet of that, and then once you refer the data sheet, you will be exactly knowing. Most of the time it would be 5 volt, I know that. But sometimes it is possible maybe 3.5 volt. So 5 volt DC would be connected to VCC and the ground would be connected to the ground pin. Okay. So that two are the power pins of your 8085. Then the second important pins are this two, X1 and X2. So X1 and X2 are basically the pin where we are going to connect a crystal. We know that what is a crystal? Crystal is basically a device, kind of oscillating device, which will generate a frequency. And any controller or any processor works on frequency. So you need a frequency base to operate 8085 or any other controller. So X1 and X2 are the pins where we are going to connect that crystal. Okay, how a crystal is connected? See, this is the connection of a crystal. Let me draw it properly rather than this. Let us say this is my pin X1 and this is my X2. So in between these two pins, I am going to connect a crystal like this. So this is the symbol of crystal. Okay, kind of capacitor, but in between the capacitor you see a square mark. So this is a crystal. And along with the crystal, you are going to connect a two capacitor, and the values of capacitor will be also provided by manufacturer to provide the stability, the oscillation, and this pin will be grounded. This is how a crystal is connected. So this will be probably 30 picofarad or 10 picofarad. We are not going into that. This is how it is connected. For 8085, it is not at all mandatory that you know how to connect a crystal. For 8051, we will see that how to connect a crystal. It can be as simple as examination. But for 8085, we will be providing less focus on 8085. That's why this is not so important. But this is how it is connected. So X1 and X2 are the pins which connects a crystal. Then starting from this pin, we know this pins. Okay, starting from 21 to 28 are the pin. Okay. This is my higher order address bus. You know that there are two buses. One is the address bus The other is a control bus, data bus, and the third one is a control bus. We know that three, but from that, these two are usually in form of buses. Okay, so we know that address bus is a 16-bit with on 8085 and 8-bit of data bus. Now to provide accommodation of 8085 on the less pin basis, like only 40 pin IC or only 40 package IC, to provide that 8085 on 40 package IC, what they have done, they have mixed up this address bus with the data bus. We have already seen that, but I am just reminding you one more time. Address bus and data bus is combined in case of 805. How it is combined? So from the 16-bit address bus, what they have done, they have separated two parts in 8-bit. One is known as the higher order address. The other one is known as lower order address. So what they have done in this higher order and lower order. So for example, if my address is D500, this last two digits are my lower order and this is my higher order. So what they have done, they have provided higher order address bus separately. And that pins for that higher order address bus is A8 to A15. Okay. So this is my higher order address bus A to A15, and a lower order address bus is combined with this data bus 8-bit. Okay. So both the size is 8-bit, so I can combine that too. And address bus and data bus is combined, and it is combinedly known as multiplexed address data bus. It is known like this: multiplex address data bus or multiplex data address bus. So where is this? So this is here. Whenever you see A along with B, that means it is multiplex address data bus. Okay. So it is marked as AD0 to AD7. So from that AD0 to AD7, actually there are two parts of this. First one is D0 to D7, that is my data bus, and the other one is A0 to A7, that is my lower order address bus. This is how this bus is combined. So these are that bits, AD0 to AD7. Now, how to differentiate that two? Like how to differentiate your address bus from the data bus? That's also important question. Let me open it in background. So to do that, to separate out this address data bus, multiplex address data bus, we use a dedicated pin, and that pin is this ALE pin. What is ALE pin? ALE is my address latch enable pin. Now manufacturer himself knows that if I combine that address bus with the data bus, someone might get a wrong operation. Whenever there is a data and whenever there is address, I have to separate that output. Like where the address is available on your address data bus. Okay, this multiplex address data bus. So what they have done, they have provided a dedicated signal known as address latch enable. This signal. What this signal will do? This signal will go high whenever address is present on your AD0 to AD7. So whenever 8085 put address on your AD0 to AD7, at that time, immediately this address latch enable signal is kind of output signal. This is kind of output signal. It will go high. So by looking at ALE signal, it will look like this. For half cycle, it will go high. So by looking at the ALE signals, you can guess whether there is address or data. If ALE is 1, that means AD0 to AD7 has an address on it. Okay. And there is a special dedicated circuitry to load that address from there. So let's see that circuitry, how that works. This can be a question in your examination. I'll show you the figure that how you are supposed to draw it. Okay. So here, see this diagram is given on this page number 97. Okay, the pin diagram as well as the other diagram that we will be using. Then what are the pins? The pin description can be asked in the examination. And the pin description is given on the next page. You can refer it from here. Okay, what should you write in examination? And yeah, this is the figure. This is the figure. It's not okay, so this is the figure how you can use ALE signal to differentiate between address and data bus. So what we do is we use this IC 74LS373. What is this? This is a latch, 8-bit latch. What is a latch? We know that what is a latch. If you provide a trigger signal, whatever on is the input side, it will save it on the output side. Like it will latch it on the output side. Okay. So for an example here, address is being provided by 8085 on this bus. So okay, so this is the address 101 and 000. This is the address, and we'll use this ALE signal to trigger this latch. Okay, so we know that whenever there is an address on the address data bus, at that time your ALE signal go high. Okay, so what we are doing here, we are feeding this to my latch as an input. 80 to 87 is the input to latch. Okay, so if there is an address would be available at the input side, and we also know that whenever there is an address on address data bus 80 to 87, at that time ALE will go high. So what will happen? This signal will go high. That means this is the trigger signal for latch itself. So I am going to trigger this latch using ALE. So you can see ALE is connected to here. Okay, so it's a latch signal. So what will happen? Immediately whatever on this address data bus will be latched toward the output side. And here now I have separate address bus only. So this is my A0 to A7, but I need an external separator to do that. Okay, so you can separate out your AD0 to 87, like you can separate out the address bus from there like A0 to A7. But how to do that? You need a separate external circuitry that is known as latch, and that latch number is 74LS373. This number is important. You have to remember this number and write it down whenever you draw this figure. Okay. So whatever is the input will be stored at the output. So now I have a separate A0 to A7. Now what if a data is there? Like, suppose 8085 sends some data over here. We know that whenever a data is sent, what will happen? ALE signal will not go high. ALE will be low. Okay, so this is 0. That means this won't trigger, and my data will flow on this bus itself. Okay. So now we know that, see, I'll show it one more time. See what happens, suppose 2005 is addressed. So on the first cycle, T1 state, what will happen? The clock will go low. As soon as the clock goes low, at that time, address will be put on this address bus. So 20 on the higher order address bus and 05 on the lower address bus. But this address is available only for one cycle, but we will require it later on while reading the memory. So while you read the memory, you will require whole address, but it is only available for the half cycle. So what we'll do, we'll use this ALE. So as soon as your address is there on your address data bus, at that time ALE signal goes high. So we are going to use this signal to latch this address. So what happens, though it is available only for one cycle on the address data bus, but what we are doing, we are latching that using a separate latch. So though it is not available afterwards, it will be available here. Why? Because we have a kind of latch here. We can say this is a kind of memory device. So it has stored this address available for one cycle for use it to later purpose. So we have this address separated address now. So we can use this address, and while the data will be there, the data won't interfere this address. Okay, because there is this IC in between which will separate out the two parts. And this IC will only enable when ALE signal is there. Okay, so this can be a question in your examination. draw the figure of demultiplexing the bus AD0 to AD7 and explain demultiplexing. So at that time you should write the theory like this, like when ALE goes low, at that time the address will be there and address will be H. Okay, so this is the theory and this is the figure. You do not have to write this whole thing, but just the conceptualize this thing. Okay, like how a data would be separated, how the address would be separated. So this is how you can use your ALE signal and you can separate out your address from the data. Now next signal. Next is a 3 signal set. In that 3 signal, sorry. Signal are this. First is this IOM bar, second is this RD bar, and third is WR bar. So what are these 3 signals? This 3 signals combined give you the information about read and write operation. Okay, whether the operation is a read operation or write operation, that information will be provided by this RD and WR bar, and IOM bar will provide you information whether that read and write operation is performed on input output or a memory. Okay. If you want to read a program or if you want to read some data, then IOM bar will go low. Okay, so whenever you are performing some operation on memory, at that time this signal will be 0, and whenever you are performing this operation, read operation on the input or write operation on the output, okay, at that time your IOM bar will go high. Okay, for memory it would be 0, and input output it will be 1. Now, if along with this you have to say this, if you have 1 on this input output bar and 1 on RD bar and 0 on WR bar, that means we are going to perform a write operation. Again, I am repeating one more time. If RD bar is 1 and WR bar is 0, that means I am going to perform write operation, though 1 is on RD bar, because this is active low kind of signal. Okay. That means this application is enabled when the signal is low. Okay. Generally, you will see a signal without bar, but whenever there is a signal with a bar, for an example, this signal itself. So when this sends a read operation, at that time, actual your signal will go low like this. Okay. So this is the indication of read operation. We have seen that already. Let me show it to you one more time. You might have forgotten that. See, these are the RD bar. RD bar goes low whenever there is a read operation. So during the opcode fetch, we have to read the memory. So at that time, RD bar goes low. Whenever the RD bar goes low, that means it's a read operation on your memory. Okay, so along with that, you can see IOM bar is equal to 0 over here. That was the status signal that we were discussing at that time. And along with that RD bar, you can also draw a WR bar, a straight line, okay, representing a high. That means no write operation. But if write operation is there, in that case, what will happen? Instead of RD bar, your WR bar or write signal will look like this. Okay. So combined with these 3 forms the read write signal, and you can form a single signal using this combination of these 3 signals. How you can do this is this. Okay. Generating a control signal. What are the control signals? These are the control signals known as MEMR bar, MEMW bar, IOR bar, and IOW bar. So what we are doing to perform that? We are generally combining IOM bar with RD bar and WR bar and directly using this signal as a single signal. Okay. Instead of multiple signal, we will just use a single signal and provide this to enable pin of memory or input or your output. So this is a MEMW. That means this is a memory read signal. MEMW is memory write signal. This is input read signal, and this is input write signal. So what we are doing? We are basically having this AND gate with active low input and active low output. So what does that mean? To explain that, we need this figure. here, let us say the memory read operation is there. So if memory read operation is there, that means IOM bar would be 0, RD bar would be 0, and WR bar would be 1. Okay, so I am writing it over here 0, 0, and 1. Now let's see which signal is activated. So this is 0 and this is 0. Okay, whenever there is a bubble, you should consider on input side it is getting 1. Okay, so AND gate 1 and 1 will get 1 over here. Okay, and as this is an active low, again it will again take the change and will get 0 over here. Same way I'll get 0 over here and 1 over here. Okay, so that is my 1 and 0. Operation between 1 and 0 will result in 0. I'll get 1 as output. Again here, again 0 is out there. Okay, again this is a NOT gate, so it will invert to 1. 1 is at the input, so again it will be inverted as a 0. Okay, so I can write it over here 0. And on the second line, this line, it is 0. Okay, so here I am getting 0, that would be resulting in 1. 0 in 1 would result in 0 again, and I'll get 1 more time. Same way in last operation, we get 0, then we will get 1, that will be 1, that would be 0. And WR bar is 1. Okay, so you will get 0. 0 into 0 will get you 0, and at the output will get 1. So actually, whenever this kind of operation is there, you get a single signal that you can use for activating any application, and all the other signals would be in the opposite state. Okay, so this is active low read signal for the memory. Same way, if a write operation is there, suppose this was 0 and this was 1, at that time what will happen? This will become 1, this will become 0, this will become 1, and this will become 1. Same way, if input read operation is there, that means input is equal to 1, read is equal to 0, and WR is equal to 1. At that time, what will happen? We will get 1 over here, we will get 1 over here, we will get 0 over here, and we will get 1 over here. Okay. In same way, for the last operation, that is output write, at that time we will get 0 over here, and all other will be 1. So you can use this single signal to perform various operations. So this is how you can generate your control signal. So this is the figure that you have to remember. You don't require to remember this figure, but this is the important. Okay, this question can be asked: how to generate memory read, memory write, input read, and input write signals using IM bar, RD bar, and WR bar. This can be a question for 1 or 2 marks where you go to draw this figure and explain a little bit about the things. So this is the pins of your control system: IM bar, RD bar, WR bar. Okay. Now the other pins. So now if you see, there are very less pins left that we don't know. From that pins, this pin, CLK out. What did that mean? CLK out is basically a pin which will get a frequency at output. Now we have connected a dedicated crystal on X1 and X2 to generate a frequency. Okay, that is generating a frequency like this. Now it is possible whenever you have some peripheral devices with 8085. Okay, 8085 along with some peripheral devices. Okay, some peripheral devices, like what kind of peripheral device? There can be a number of peripheral devices. But suppose here I have connected, let us say, a serial unit, serial communication unit. Okay, so that can be used to perform a serial communication. So at that time, it is possible this unit requires a frequency to operate. So again, you have to connect a separate crystal to this IC. So at that time, what you can do is you can use the output frequency of 8085 and you can connect it directly here. So a dedicated crystal is not required one more time to operate this unit. Okay. So this, how to get that output frequency from this? So basically, your CLK out pin is the output pin which will have the output of a frequency on the screen. Okay. So basically, whenever you connect the crystal over here, automatically this pin, CLK out pin, will have a frequency. Okay, which frequency will be there? Operating frequency. So a 2 megahertz crystal is connected over here. I will have only 1 megahertz at the CLK out. Okay, why? Because my F operating would be half of the crystal. That's the frequency we use inside 8085. In same way, that same frequency will be available as the output frequency. Okay, or it will be available at this pin, and you can use that signal for any other peripheral devices like a serial communication unit. Okay, so this is why we have the CLK out. Other than that, same way, now sometimes our mobile hang, what we do, we provide a reset. Same way, to provide this reset on your 8085, we have this pin reset in. Okay, this pin itself state reset would be given through this pin. So reset in, now you can see a bar over there. That means reset pin is active low. So to reset your 8085, what you have to do? You have to pull down your reset pin. Pull down means you have to connect a 0 to that pin to make a reset. Okay, for few seconds. Like it can be 3 seconds or 10 seconds. If you provide a low signal on that pin, just a moment. So here we have this reset pin. So you have to connect a ground somehow. So okay, so generally how it is done. Suppose you have this reset pin. This is my reset pin. Okay. So what I am going to do, I am going to connect a switch with the ground, and this would be my switch. Okay. Generally it would be a push button, and other than that, what I will have, I will have a plus 5 volt like this. So this would be my reset circuit. What will happen? Whenever I press the switch, at that time, the current through this 5 volt will flow like this, and actually what this reset would be at 0 volt, because there is no resistance in between. Okay, so that would be at 0 or ground, and whenever you release it, it will perform a reset. Okay, but all the other time it would be connected with plus 5 volt. Okay, because this would be open. So this is how you can perform a reset. Now same way, your peripheral may require reset. If you reset your main circuit, and if you are working with the peripheral device, let us say one more time a serial unit. So serial unit might be performing based on the instruction of 8085. 8085 is sending some instruction to perform some task to this unit. Now when I reset this might go confused, like what happened. So for that, you have to reset this device along with that. So again, whenever a reset is performed in 8085, at that time, 8085 have a dedicated reset out signal which can be used to reset the other peripheral circuitry. So this is that reset out. Yeah. But it is output signal. When it will set a reset out signal, it will send as a reset out as a 1. Okay, signal will be high. But when it will set, whenever you provide a reset in a low. Okay, so what I am going to do, I am going to perform a reset by pressing this button. At that time, this reset out will go high, and it will indicate that you can use this signal. It is optional. Like if the other unit don't require reset, in that case you just keep this signal. This is optional signal. But if the other device requires a reset, at that time you can use this signal reset out to reset the other peripheral device as well, along with 8085. So you just provide a reset over here, and all the other devices will reset out. Provided that you have to connect, you are connecting this signal to other units. Okay. Clear? Now there are this signal S1 and S0. These two are the status signal. Along with IO and bar it will work. Okay, along with IO and bar it will work. So these are the status signals. So what status is will show? It will show whether which cycle is performing inside your 8085 at this moment. For example, opcode fetch or memory read or memory write. For each separate signal, you have a separate S1 and S0. So when it is needed, it is just needed for troubleshooting. Let me show it to you. Yeah, this is that signal. So along with memory signal, you can use S1 and S0. Okay. If opcode fetch cycle is performed, at that time S1 would be 1, S0 would be 1, and IO bar would be 0. Why? Because opcode fetch is always performed in memory. Same way, memory read is S1 would be 1, S0 would be 0, and memory write S1 would be 0 and S0 would be 1. At all the time, memory is operated, so 0, 0, 0 is the signal. If you are performing input read, at that time your IO bar, okay, so input operation is there, so obviously IO bar will be 1. Along with that, your status signal is same as the read memory read signal 1 and 0, but IO bar differentiate the operation. It's again read operation, but on input output. Same way, input output write is 101. Then this interrupt acknowledgement, halt and hold and reset. Okay, this is a reset. So when you perform reset at that time, your input output will go on high state, okay, high impedance state, and your S1 and S0 goes to accept. What is accept? It may be 1, it may be 0. It doesn't declare every time. Okay. So that is the scenario. But what are these other three? Interrupt acknowledge, halt and hold. That are the other three operations. So I have told you that most of the time we perform the 5 operations. Of course, memory, hyperread, and input write. Other than that, there are these operations possible using your 8085. Okay. So while you perform this operation at that time, it would go only 2 to 5% of the time it is performing this task. Okay. But at that time, your status signal will change to something else. Okay. So first, let us understand what are that signals. So the very first is interrupt. You have to understand interrupt first to understand that status signal of interrupt acknowledgement. So what is the interrupt? In layman's term, we say interrupt is, for an example, right now I am taking lecture and the call was there, so I have been interrupted. Whether I have unmuted or not. So at that time, I have been interrupted. How I have been interrupted? I have been interrupted using the call. I am doing my task and the call was that, so I am interrupted. Same way, when 8085 performs the routine programming at that time, you can use the interrupt. Why we need interrupt? That's very important question, like why we need an interrupt. So generally what happens, you have a different task of priorities, two different tasks. For example, if you have a different kind of alarm system in your home, first is like very basic wake up alarm that we use to wake up. The other can be a doorbell alarm whenever some person is there. Okay. But we respond a little bit lower on that two kind of alarms. But there is a fire alarm. We might not have it at home, but in corporate offices or in industry, you have a fire alarm. Whenever a fire alarm rings, the very first immediate protocol is that you have to leave all the tasks you are performing and quickly gather at the safety point. That's the task. That is the task. Okay, so whatever you are doing, okay, but the most priority is given to the fire alarm. So that's kind of interrupt again. I am doing my general task and fire alarm rings. At that time, that's an interrupt. But that interrupt priority is very high. Okay. So same way here in 8085, if you are performing a routine task, so we know that a program counter will look after the program. Okay, it will execute the program line by line. Okay? But in between, there is an important task that has to be performed using 8085. For an example, a sensor is there that sends the heat and it sends the fire signal to 8085. This is just an example, okay? A fire signal has been sent to 8085. So if I am performing this task, so what will happen? A fire signal is there on 8085, but I am not going to look at that until and unless its turn is there. So I am doing a routine task. Okay, after like for an example, what is that? If you are in class, I am writing on board. After each 10 seconds, I will look back and I will ask whether there is any doubt, whether there is doubt. So if someone has raised the finger, after 10 seconds, I come to know, like, or after 1 minute, let us say 1 minute is the interval. So after 1 minute, I will come to know that someone has doubt. Okay, whenever I see the hand. So that's one kind of signal, okay, raising hand. But whether someone has raised a hand or not, how can I identify? Once I move back from the blackboard and towards the students, at that time I will come to know. So it may be possible the hand has been raised for 1 minute. It may be possible it just has been happened before 2 seconds, 10 seconds before. So I don't know what is the time frame before that hand is raised. But when I come to know when the routine time comes for that particular task, that's scanning the student for the doubt. When that particular moment comes, then and then I come to know that student has a doubt. But the interrupt way is the roundabout. Like how the interrupt way works. So using interrupt way, what we are doing is basically the student will, rather than raising the hand, will interrupt me by asking a question like, "Sir, I have a doubt." So I'll come to, my immediate attention would be there. Stop at the blackboard and I'll return to the students like, what's your problem? So interrupt is just that kind of signal. So a fire alarm or any kind of a priority signal that has to be done immediately can be, that kind of task can be assigned to 8085 using this interrupt signal. Okay. So how we actually do this, we are going to see this with an example when we learn 8051. But right now just understand the theory of interrupt. What is interrupt? We will be having a practical of interrupt. Okay, I'll show you the practical what happens when interrupt occurs. So what you are going to do, you are going to connect your fire alarm system using your interrupt signal. Okay, there is a dedicated pin to provide this interrupt signal, and that dedicated pins are this: trap, RST 7.5, RST 6.5, RST 5.5, and INTR. There are 5 interrupt signals. Okay, so you can connect 5 different interrupt using your 8085. But which one will be the first one to execute? That's again a question. Okay, so a priority is given to each and every interrupt. The trap being the most important, and this would be a least important. Okay, least important means again it will hold the general star, but if these two raise at the same time, a student asks about the down that if principals are enter, which one I am going to attend first? And obviously I am going to attend principal C plus one. Okay. So that's the way. Then I come back to student. Okay, so that's the priority. A fire alarm will be on most prior, but some other task can be on least priority. Okay. So what will happen if this is executing at that time? If this comes, again this will be hold out and I'll execute this. Once I complete this, then I'll come back here, then I'll come back to the wherever I was working. Same way to the student example. If I am taking the lecture, student asks it out, I'll hold whatever I'm writing at that point. Then I'll solve it out and then I'll come back to the blackboard and I'll start again. So that's the intro. Okay. Okay, we'll stop here for today's lecture. It's already like 10. If you have any doubt